Hello, everybody, and welcome to our first lesson in our trigonometry unit, angles and ratios. So today we are looking at rotation angles and reference angles. So most of you have looked at angles before in other courses, so hopefully this is a bit of a refresher, and then we're going to start using some vocabulary that you might not have seen before, and we'll walk you through that. So we'll just go through some of this. So let's look at angles in standard position. So a rotation angle, maybe I'll just highlight the vocabulary words. A rotation angle is formed by rotating an initial arm or initial side through an angle about a fixed point, which is usually the vertex. So there's a great example over here. This is just like what you would think of an angle is. So the initial arm is your starting point. The terminal arm is how far we've moved or rotated, and that makes the angle that section right there. So just what you think an angle would be, it just makes sense, right? A positive angle results from rotating around this way, and a negative angle results in a clockwise rotation, so rotating around this way. So the angle in the above diagram is said to be in standard position, and we'll talk. Well, it actually says it right here. So standard position means that on a coordinate grid, on an XY grid, standard position means the initial arm is along the positive x-axis, and then the rotation is about the origin. So, our XY plot looks something like this, X, Y. And so if we're looking at an angle in standard position, that means that the initial arm is going to be along the positive x side, which is normally where we start when we are looking at angles, unless we're looking at compass bearings. And then the angle is formed by going rotating about the origin. The origin's the 0, 0 point. So, for example, if this was our angle, that was our terminal arm, then that would be an angle in standard position. It starts on the positive x-axis, and it rotates around the vertex or around the center. So a good example is right below. So this one shows the angle 220 in standard position. So it's measured from the positive x-axis. It goes around counterclockwise. That's a positive angle. So that is angle 220 degrees. So what we're going to do is sketch a rotation angle in standard position and state the quadrant in which the angle terminates. So there are 4 quadrants on a coordinate system, and they are numbered in a really weird way. So it goes quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And for some reason, it's always Roman numerals. And I think it goes that way because when we're measuring an angle in standard notation, we are moving from 1 to 2 to 3 to 4. All right, so let's do 120 degrees. Well, we don't have to get it exact, but we do need to get it in close enough. So we know that if we start along this arm, this is 0. Straight up is 90 degrees, and then the negative x is 180. So our terminal arm is going to be between 90 and 180, and it's going to be a little bit closer to 90, so I would draw it somewhere right there. And the angle would be like that. And this is the terminal arm is right here, and that means this is in quadrant 2. So if you want, pause the video, try the next 2, and then I'll go over them. But if you want to just keep listening and watching, do that as well. So the next one is 309. 309. So it's going to be more than 270 and less than 360. So we're going to go all the way around. It's going to be probably closer to 270 by a little bit. So maybe I'll stop there. And then we'll put a little arrow. And this is in quadrant 4, right? Because the terminal arm is right here. And this is the 4th quadrant if you look over there. And last but not least, 17 degrees. Well, that is basically, it's a really small sliver. So that's our angle right there. And this is in quadrant 1. Hopefully this is making sense. All right, so now we have 3 questions that say draw the rotation angle in standard form. So you can see that they all actually have the same terminal arm. We know that we want to be starting from the positive x arm. So in this case, they're looking for a rotation of 150 degrees. So I think that would go just like that, right? 150 degrees. The next one says a rotation of negative 210. So negative means we're going the other way. We're going the opposite direction. So positive angles go around counterclockwise. Negative angles go around clockwise. So it's not more than 360. So that means we're not doing a full rotation. 360 is a full rotation. So it's going to be the opposite direction and something like that. The next one's a little bit tricky. It's a rotation of 510. It's positive, so that means we're moving around that direction. So it's more than 360, which means we need to go all the way around to 360 and then probably again one more time. And that's the angle there. So that terminal arm, you can see it's the same terminal arm. It can be expressed in a few different ways. It can be expressed as a rotation of a positive 150 degrees. It can be expressed as an angle of negative 210, and it can be expressed as an angle of 510 if you go one full circle and then measure. And you can do that as many times as you want, really. Like there are an infinite number of possibilities. So if that was your arm, and you really wanted to, you could measure this angle around and around and around and around. So every time you loop, it's 360. So there's 1, 2, 3 loops. So 360 plus 360 plus 360. So 3 loops plus this extra bit, which is 150 from here to here, plus 150. And you could say, I don't know where I put my calculator, which is great. You could also say that that terminal arm is measured as 1,230 degrees, if you really wanted to. So the angles with the same terminal arm are called coterminal angles. Since 150 is the measure of the smallest positive rotation, it is called the principal angle. So all of those angles produce the same terminal arm, but the smallest positive one is going to be the principal angle. So the principal angle always is between 0 and 360 degrees. And again, what I stated on the right here is that there are infinitely many angles that are coterminal with a given angle. So you can have as many combinations really as you want, positive and negative, because you can just keep going around and around and around. All right, so it says here the point P lies on the terminal arm. So that's the ending arm, right? The final line. So the point P lies on the terminal arm of the angle theta. Draw the angle theta in standard position. Well, hang on, here we go. Let's draw our XY coordinate. XY. We know that if this is our point 2, -4, this is our X value and our Y value. Let me scroll up here. So positive 2 on my X is somewhere, it's just a sketch, right? It doesn't have to be exact. It's positive 2, -4 on my Y, -1, 2, 3, 4. That point is somewhere right there. So if I were to draw that from the origin, they're saying that that point P lands on the terminal arm. So I've drawn the terminal arm. Draw the angle in standard position. So it's going to start on the X, positive X, and go around to be in standard position. And this is in quadrant 4, if you wanted to do that. The next one, the point's a little bit different. It's -5, -1. So we have our xy. Again, our points are in x and then y. So if I wanted to plot that point, I'd go to -5, 1, 2, 3, 4, 5, and -1 in the y. Plot my point. And there's my terminal arm. And then always the angle in standard position starts on the positive x and moves counterclockwise. So that's my angle right there. Hopefully this is starting to make a little bit of sense. I know it's weird, but you end up using this a lot in Pre-Calc 12 and Calculus 12. So good skills to know and good words to know, and yeah, helping you out for success in your future. The last one I want to talk about is reference angles. So our reference angle is the acute angle. So that's acute is less than 90. Less than 90. So it's the acute angle formed between the terminal arm. So it's between the terminal arm and the x-axis. So for the example over here, the diagram shows the terminal arm of a rotation of 141 degrees. So that is right there, 141 degrees. That is the angle in standard position. But the reference angle is always from the x-axis, the closest x-axis. So your reference angle would actually be from here, measure it upwards. And that would be 39 degrees. And if you didn't know how to find that, you know you're starting at 180, so it would be 180 minus 141, and that would give you your reference angle. So in this case, the standard angle is 141, the reference angle is 39 degrees. So it says here, in each case, sketch the rotation angle and state the reference angle. So for this one, it's 243, so it's going to be between 180 and 270. It'll be somewhere in there. So the rotation angle is going to be that. Maybe I'll make that a little bit nicer. 243. But the reference angle is from the nearest x-axis, which is positive 180. So that would be your reference angle. And to find that, you could do 243 minus 180, and you would get a reference angle of 63 degrees. 337, so let's do 337. That's going to be pretty close to 360. We're going to go all the way around the circle. So it's going to look something like that. That's 337. And in this case, our reference angle, it's always going to be positive, and it's from the closest x-axis, so it's actually going to be right there. So in this case, to find that, we can do 360 minus 337, and that gives us a reference angle of 23 degrees. The last one is 70. So if I was to draw 70, it'd be somewhere like there, maybe. 70. So if we are drawing the reference angle in this case, the closest x-axis is actually the initial arm. So the reference angle is going to be the same thing. So our reference angle will be 70 degrees as well. Cool. So hopefully we're understanding reference angles a little bit. So on the grid, draw a reference angle of 58 degrees in each quadrants 1 to 4. Okay. So maybe I'll do this in a different color. No, that works. This one is 58 degrees. This one also 58 degrees. This one 58 degrees from the 180. And then this one also 58 degrees. So we'll label this 1, 2, 3, and 4 because those are the quadrants it's in. So in quadrant 1, it says state the measure of the rotation angle in each quadrant. So that's just the standard angle. So in this case, the rotation angle for quadrant 1, well, it's going to be the same, right? It's going to be 58 degrees. Let's look at the rotation angle for quadrant 2. And that is going to be starting with your positive x. You're going to go all the way around to there. So that one's going to be 180 minus 58. And that will give you 122 degrees. Right, because it's going to be, to measure this angle right here, Q2, you want to know how far that is. Well, it's 58 degrees less than 180. Hopefully that makes sense. Let's see what other colors we got here. Let's do Q3. I'll scroll up a bit. Q3 is going to be this rotation angle. I'm starting to run out of space. And in that case, it's going to be 180 plus that little distance there. So 180 plus that, I mean, not that distance, that rotation. So that's 180 plus 58, and that will give you 238 degrees. And then the last one is going to be, let's go with, I don't know, yellow maybe. The last one is going to be the rotation angle for quadrant 4. So I'm going to just erase that. So if I'm doing that for quadrant 4, I'm going to go all the way around to there. So this is 270 here, 180. So in this case, it's going to be, oh, actually, it's better to do it this way. I apologize. This one's 360. So we know this arc right here. So it's going to be better to do it as 360 minus 58 degrees, and that gives us 302 degrees. There we go. Let 5, 8 be a point on the terminal arm of the rotation angle in quadrant 1. So let's just draw a picture. I'm just a much better visual learner. So 5, 8 is going to be x5, y8. So that'll be P. Let P be a point on a terminal arm of the rotation angle in quadrant 1. State the coordinates of point Q, R, and S, which are on terminal arms of the rotation angles in quadrant 2, 3, and 4, respectively. State the coordinates of points Q, R, and S, which are on the terminal arms of the rotation angles. Oh, I think it must be using the same one for, oh, it's part of the last question. Okay. So they're saying point P is actually like on this arm. And then they want a point on the other arms as well. So if we do this, okay, that makes more sense. Okay, so because there's some symmetry, point Q is going to be over, we might as well use the same colors. What color do we use for that? Q will be here. S is going to be over here. And R will be right there. So this one is 5, 8. And if they are mirror images of each other, that means Q is going to be, well, it's the same Y value, but it's the opposite X. So it'll be negative 5, 8. And then R is in the negative quadrant. It's negative X, negative Y. So it's negative 5, negative 8. And S is positive X, negative Y. So it'll be 5, negative 8. That was a weird one, but hopefully that made sense. Okay, I try to keep these short, but it's my first one I've done all year, so it's just getting back into it, and I don't want to go through all of this with you. So we'll go through this chart here. It gives you a reference angle and in which quadrant that is in, and it wants to know the rotation angle. So maybe I'll just do, I'll do them all. Why not? So it's saying we have a reference angle of 25 degrees in quadrant 2. So that means the angle is going to be somewhere, we're doing a sketch, it's going to be somewhere over here. So it means that angle is going to be 25 degrees. The rotation angle is going to be all the way around from the positive x. So it's basically going to be 180 minus 25, and that gives you 155 degrees. Let's do another one. Reference angle of 60 in quadrant 4. 60 in quadrant 4 means it's over here somewhere in quadrant 4, and that 60 is right there. So the rotation angle, which is all the way around, is going to be 60 less than 360. 360 minus 60 gives us a rotation angle of 300 degrees. So now we're doing 8 degrees, but in quadrant 3. So quadrant 3 is this guy over there, and it's only 8 degrees, so it's somewhere like that. It's very close. The rotation angle is going to be all the way around. So it's going to be 8 degrees more than 180. So it's going to be 180 plus 8, and that gives you 188. 39 degrees in quadrant 1, so somewhere like that. The rotation, or the reference angle is right there. The rotation angle is actually going to be the same thing. That one's always a nice one. So in quadrant 1, it's always the same. The reference angle and the rotation angle are the same. And the last one, at 90 degrees between 3 and 4. So this one's 3, this one's 4. So that angle is actually going to be straight down because that's 90 degrees. So if you're just measuring that from over here, we know that's one of our known angles, and that's 270 degrees. Or if you wanted, it's 180, because that's 180, plus 90, which gives us 270. All right, so it says determine, sorry, that's my phone. Last one, determine 3 angles between 0 and 360 which have the same reference angle as the rotation angle of 256. So if you're not sure, draw a quick sketch. I like that. 256 is somewhere down here because that's 180, 90, 0, 360, and that's 270. So it's saying that 256 is the rotation angle. The reference angle is going to be we know the rotation, so it's going to be 270 subtract 186, or 256, sorry, is that what we want to do? Why am I throwing myself off here? Oh, sorry, we can't measure from 270. No wonder I was getting messed up. Our reference angle has to be that one. It has to be measured from the x. So what you can do is you can say 256. That's what we're going to do. 256 minus 180. Wow, my brain had a little moment there. And that is going to give you a reference angle of 76. That means that we have a reference angle of 76. We want three other angles that have a reference angle of 76. So it's 3 other rotation angles. So there's one, we can just use 76. So in quadrant 1, using reference angle 76, we have a rotation angle of 76. In quadrant 2, if we use a rotation angle or a reference angle of 76, we have 180 minus 76, and that gives us 104 degrees. And then in quadrant 4, we've done quadrant 3 already. In quadrant 4, if we use a reference angle of 76, that means our rotational angle is going to be 360 minus 76, and that gives us a rotational angle of 284. Hopefully this is making sense between rotation angles, reference angles, standard position, and things like that. Thanks for watching. Don't forget to like and subscribe.